our universe may be made up of equal parts matter and antimatter. Now, everyone's heard of antimatter. It's been the plot of quite a few movies, and I think most people understand. And this has been, we've created antimatter in laboratory settings, high velocity particle accelerators, plasma generators, things of this nature. When matter and antimatter combine, this is a process known as annihilation, and it produces a tremendous amount of energy. And so we have not observed any antimatter in situ yet in our solar system, but our furthest probes only go out to the edge of the heliosphere, which is about maximum, I think Voyager 1 now is at maybe 160 astronomical units. And there are some very compelling ideas out there that every star could either be koinomatter, which is regular matter, or antimatter. So matter or antimatter. And at the boundary between stars, there would be a Leidenfrost layer where these two different types of matter are meeting, and because their annihilation is such an energetic process, it actually pushes them away from each other, creates this thin Leidenfrost layer, which is very highly energized, but there's so much matter in between that Leidenfrost layer and, for example, our solar system. This is about 2 light years or so if we consider, for example, our nearest star system, the Centauri. That's about 4 something light years away, 4.2 or so. That all the extremely energetic gamma rays would be absorbed by the matter in between that Leidenfrost layer, and the interactions would be fairly low, and so it's effectively unobservable until a spacecraft was to pass into it. So what's so interesting right now is that we have an interstellar visitor. And so it's very likely that everything that's in our solar system is likely to be composed of regular matter as we know it, though that is also potentially not exactly the case. But things from outer space certainly could be composed of antimatter, or rather interstellar space, right? If they're coming from way far out, for example, 3I Atlas here, observed, first picked up July 1st. We got a whole bunch of measurements in the first few days. Most astronomers are saying that this is a comet. It has a coma. This outer envelope of material surrounding it is about 2 times the diameter of the Earth. So while the inside of this, the actual comet, they estimate as being 1 to 10 kilometers in size, approximately, pretty big range, the actual thing that we're observing with ESO imagery is about 2 times the size of Earth. And we see it here, this is taken on July 3rd. We see Atlas 3I, and this is a 13-minute capture right there. So it's going off to the right. Boom, 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 boom. It's moving about 61 kilometers per second, which is pretty fast. So it's zooming in from interstellar space. And if you look at our orbit here, it's nicely aligned with the ecliptic plane, and it cuts through, goes a little bit south of afterwards, has a slight deflection in its orbit because of the fact that it's getting within the orbit of Mars, but it's also traveling again at 61 kilometers per second, so it's only a slight deflection, continues on, and hopefully nothing happens. That is what we are hoping for. But what you will notice is that if we go forward in time here, and this should be right at the very end of September, beginning of October, we see that Atlas is getting really close to Mars. Now I'm going to explain the antimatter thing more, okay? So if you're watching this alone, welcome. I'm your host, Stefan Burns, geophysicist, space weatherman, cosmic dude, your cosmic bro, here to talk about things that you have to read the books to learn, because I am blown away that this idea of stars being composed of either antimatter or matter, and so long as they're in their own system, right, stable, blew me away. It makes a lot of sense. And there's been a lot of work done on it, but because of Big Bang cosmology, it's been ignored. And they've been trying to explain the energy of the cosmos and its expansion as a result of things like dark matter and dark energy, and they have all these ideas for it, some big initial explosion. But the nail has been basically put in the coffin of the Big Bang Theory. So there's some serious flaws with it. And this takes us to perhaps a more cyclical understanding of the cosmos. I'll be sharing a lot of these ideas. They originate from the book Cosmic Plasma by Hans Alfven. So this was released more than 40 years ago. Fantastic read, really mind-bending in many ways. I'm glad that I read it. But there's no reason to think that the universe couldn't be composed of equal parts matter and antimatter. It doesn't have to be homogeneous. It can be heterogeneous and spread out and differentiated. But it makes sense that there's a natural symmetry to the universe. Why would the universe be asymmetric in matter and antimatter? Because if they're made in equal proportions at the Big Bang, let's say, then how is it that matter, like anytime antimatter, where would the antimatter go without the matter taking it away? Because that's annihilation. Is that the two meet and they get annihilated, just release pure energy. So it's more likely in my mind, now that I've learned this, I think it's more likely that the universe is composed of equal parts and there's a differentiation process that occurs. And so at what scale does that occur? Does that occur at the solar system scale? Do we have antimatter in our solar system? Perhaps little chunks of it. There are these ideas about how that could survive for some time. But based off all our observations now going out to interstellar space, no. We think most likely that antimatter doesn't begin until at a minimum another star system. Perhaps it starts at a star cluster, right? You get a whole cluster of stars that are antimatter. Or even at galaxies, some galaxies, parts of it will predominate in certain types of matter, quinomatter, antimatter, right? It's probably all the above. So maybe all the stars in our nearby area are composed of regular matter like our star because they came and formed out of the same interstellar medium. Or perhaps there's a pretty even mixing of these things. We don't know where this interstellar visitor came from. So if we just back up really quick, some of this may be new information to you. If you just accept that there is potentially antimatter star systems out there, and the universe isn't 99.99999% matter and the other rest, the dust, antimatter. If you set that, let's say it's 50-50, which makes a lot of sense, and our spiritual wisdom accrued over thousands or even tens of thousands of years would speak to that, the yin-yang philosophy, that there would be equal proportions. And so therefore this could be composed of antimatter. If it flew in from a system that was primarily composed of antimatter, our new interstellar friend here, 3I Atlas, then that could be the case. And so the question I have is, here on October 1st, look how close Mars and Atlas get. Now, I do not know if we have gravity measurements of Atlas, okay? So this coma envelope is specifically about 25,000 kilometers across, again, double the diameter of the Earth, based off of current astronomical explanations and ideas, of which a lot of it's very outdated, honestly. They estimate that the size of this is 1.2 to 11.2 kilometers. Now, if it was larger, I imagine we get some sort of gravitational signature that could be detected. So whether or not that has been done, I don't know. I know that there are these, I think it's LIGO, or at least Virgo, I know, in Italy. It's like a large gravitational array. This can help us determine perhaps the size of Atlas. But I'm just, if its coma size is twice the size, the diameter of the Earth, potentially a large object is in there, and we don't know. Because what you will have at the boundary of matter and antimatter is you have this annihilation process. Now in space, plasma is pretty thin, and solar activity recently has been lower. May, we only had like less than 80 sunspots. June was just over 100. July, about 120 something. So we've been slowly going up. It is solar maximum, but if this is flying in and not interacting with all that much plasma in interplanetary space, the rate of annihilation will be quite low. And also consider since if this is antimatter and it's traveling through a matter-filled environment, it'll form that Leidenfrost layer. Now, Leidenfrost layer. Now, if you don't know what that is, it's what happens if you get a pan really, really hot and you put a drop of water in it, and it'll beat up because it's producing steam, and that actually insulates the water and allows it to hover around on that pan for 5-10 minutes, depending on the size of it, because it has this insulating effect. And so the idea is that when antimatter and matter combine together, you would actually, like if there's a large antimatter object flying through interplanetary space composed of matter, it would have a Leidenfrost effect. And as a result, it'd actually be fairly insulated, and it could travel and does not immediately annihilate because there's just simply not enough matter to do that. And the matter that is getting close is actually getting pushed away by that pressure created. So there's actually not much interaction. It kind of just zooms through on its own, maintaining antimatter coherence. So if that is the case, this object could perhaps be larger, and also if it is antimatter, it can be very, very destructive. Because if this was somehow to impact something, imagine the effect of that. If this is at a minimum, let's say even a kilometer across, a kilometer of antimatter, we don't know what that sort of shockwave would look like if it hit Mars, right? If this thing hit Mars somehow. Now, the orbit does not suggest it's going to do that. Again, 61 kilometers per second. It's slicing north of Mars here. I don't have the exact measurement, but we can kind of scale it out there. It's not passing super, super, super close to Mars in such a way that's like we should be frightened or anything. But there are perhaps dynamics that we are unaware of with these things. This is only the third interstellar visitor that we had. The first one, Oumuamua, was in 2017. So this is the third interstellar visitor that we have seen that we really just don't know how these things are going to interact. We think is this going to go through. We have had comets fly in before and stuff, but we just simply don't know what's actually going to happen here. And so you could speculate that perhaps some antimatter-matter dynamic actually creates an attraction between them. I don't know. It's possible. I'm wearing this shirt today, Sputnik, because this is 1957 right here. So this is our first probe that we launched out into space. 1957. It's not that long ago. In terms of understanding the Earth, the solar system, the sun, space, the cosmos, we're thinking billions of years, perhaps more. So this certainly could be well within the realm of possibility. Maybe there's a 1 in a million chance that an interstellar visitor comes from an antimatter system. Well, it's still 1 in a million. Just because we've seen 2 other interstellar visitors with the Oumuamua and I think the other one's like Boris in 2019 doesn't mean that we have the complete record of the sort of dynamics at play when you have a high-speed interstellar visitor passing through the solar system. So if this was, and I have a lot more to cover too, but if this was to impact, then that would imaginably, if it was antimatter, create a massive solar system shockwave. And that could trigger, I would think, some sort of solar flash, where you get the sun then to respond by having a big release of energy to push everything back out. I don't know. These are all ideas. So yeah, some very interesting things happening at this moment in time. We had this super close approach of 3i Atlas to Mars on these dates here. And this is just something to watch in general. I personally think that there is a natural innate balance to the universe, this yin-yang principle. And with the yin-yang logo, we can see some of these clues. You notice how you have the other polarity nested within. So you have some of this black within the white, and you have some of the white within the black. And then it's this fractal pattern. So if you do have this symmetry of matter and antimatter in the universe, which actually explains a lot of things that the Big Bang cosmological perspective cannot, explains all the excess energy that we observe, then you would have this mixing that occurs at different scales and ratios. So I think it's very, very possible. Let me show you Oumuamua, what happened in 2017. Okay, because there's more than just one idea here. The antimatter idea is one idea of what this interstellar visitor could do, what it could mean, and more. Here we have our solar system, and we see the orbit of Oumuamua. This is our first interstellar visitor. This is 2017. This is right around September. September 9th, it reached perihelion, right there, September 9th. So we have an exact date. September 9th, Oumuamua reached perihelion and actually cut within the orbit of Mercury. So it got very close to the sun. And you can see that it wasn't traveling as fast, or if it was, because it got closer, it had its orbit more bent by the sun. September 4th to the 11th, here's our solar activity. We had multiple X-class flares, including the most powerful X-class flares of recent times, with that one there and some more X-class flares. And Oumuamua at the time was over here roughly. So it actually was increasing in activity, as you can see, as the sun was rotating towards Oumuamua. So we've already seen how interstellar visitors, these comets or whatever they are, maybe alien ships, that's another idea. We'll talk about that a little bit. As they get in close to the sun, they seem to provoke the sun and trigger enhanced solar activity. We can see that as well with our comet here, Tsuchinshan, from last October. We had a comet come in from the Oort system, the Oort cloud, right, surrounding our solar system. At least it's hypothesized that it had a high orbital inclination, got on really close, flew in between the sun and the earth. There's Mercury, just like this. Look at all the solar activity that we had when Tsuchinshan flew in close to the sun. And look at that cometary envelope that it has. So even under normal plasma dynamics, let's say this is all normal matter, and this has this envelope of plasma around it. Even under these dynamics, it can still trigger significant shifts in the solar system, whether it's interstellar or whether it's from our own system, but coming in highly elliptically and then shooting right back out. We see enhanced solar activity around this time. And it was right on October 10th that we had a G4 plus storm or a G5 minus storm, depending on how you kind of look at the data. So a very powerful solar storm right up there at basically the highest classification. So we see these sort of things are possible with these large objects that pull in close to our solar system, but we really don't know kind of what it means in the long run. Their composition and where they're coming from and how they can fully express themselves. We've seen enhanced solar activity, but perhaps there's a lot of other ways that these sort of objects could perturb the solar system. So we also have some incredible planetary geometry with 3i Atlas this fall. This is October 22nd, 2025. And look here, we have 3i Atlas. If it has survived its approach to Mars, it is now here, in exact opposition to the Earth with the sun in the middle. And you'll notice that Earth has this alignment with Mercury and Mars there. So the line going from Earth to Mars does happen to cut right through Mercury. We see Venus there, and they are in this square pattern like this. And Earth is aspecting all of these. We also notice that the angle right there is the same. So it's almost like an isometric triangle. So really interesting planetary geometry, and that speaks to there being effects gravitationally and electromagnetically and how that could influence the solar system. So as 3i Atlas continues to zoom in, we are going to learn a lot. And ideally, we would actually be able to ready, scramble, and send a probe to it. If our space agencies were good and enterprising like they were back in the day, we would send a probe to 3i Atlas immediately to try to understand its composition so we could get in situ measurements of interstellar space, especially interstellar matter. So until that's done, you cannot rule out the idea, the hypothesis, even the theory of interstellar space being equal ratios or close to it of matter and antimatter. We simply don't have observational evidence. And observational evidence needs to be the foundation of cosmology. Because if it's not, then you're not interpreting reality. So that is very important. But this suggests that there is a very powerful energetic field cymatic pattern that is associated with this object. So I think we're going to, at a minimum, expect increased solar activity this fall. And it's also modifying all the planetary resonances that are active this fall. because we have really strong planetary resonances right now this summer, and then we have really strong planetary resonances early in 2026 because of how the planets are grouping together in a conjunction, specifically Saturn and Neptune, but also this harmonic configuration with Pluto and Uranus to Saturn and Neptune and more. But now, all of a sudden, the fall, which was originally, from that perspective, the quiet period in between the two climax moments, now looks like they're the border on top of whatever the heck this means for us energetically. So we also have that potential. Now, another idea for 3i Atlas, and here again we see 3i Atlas, 13 minutes of photos taken on July 3rd by ESO's Very Large Telescope. So the other idea proposed for 3i Atlas is that it's in fact perhaps an alien craft. And the reason why some people are suggesting that, there are papers linked in the video description, is because of its unusual orbit. And so we see again here getting close to Mars, but look how close it is along the ecliptic plane. It's basically flat along the plane of the planets. And we see that very clearly here again with our Sky Live model. And so the argument is that if aliens wanted to probe what was happening with the solar system, more specifically Earth, they would shoot something out along the ecliptic plane and they would have it so there would be an opposition with the Earth. So if you go forward here, when we go to this moment in time right there, the day of that planetary sequence I talked about, this is on the 22nd of October, this will be hidden by the sun. So we won't be able to see 3i Atlas, okay? And so if this is an alien probe, that's perhaps when it would deploy its technology, because it would be hidden in plain sight effectively. And it's not so close that we can easily go and check it out. Perhaps it's also, if you consider this from an alien technological standpoint, perhaps this is also when it deposits and lands on Mars, right? All these things are in the realm of sci-fi at the least, and as we're learning, our reality is increasingly becoming sci-fi. So maybe it actually does this flyby to Mars so it can drop off whatever it needs to drop off there. Robots, AI, colonies, we don't know. These are all ideas. But a lot of people are talking about how this could be alien in origin. So there is some interesting new data from another source as it relates to perhaps unusual activity in our skies. So we see that right here. Some researchers went back and examined the first all-sky survey that was done in the 1950s. This is the Palomar All-Sky Survey. And so we basically just took a whole bunch of photographs of the sky, but it's taken a long time to digitize and process this data. Well, they started to do that, and they found what they call these, they found multiple and what they call transient aligned events. And so you see that here. We see two dots, a dot, and two more dots. And then we also see stars all around. And if you didn't have them highlighted, and this is the only thing you saw, you wouldn't think anything of it. But we have this secondary exposure. And we notice that everything else is in the same position, but these transient aligned events are gone. These 5 weird reflections are gone in this follow-up section survey of that sky. And they found a lot of candidates in these records for this. And they found a lot less of these records on the shadow side of the Earth. So that what that would indicate is that these objects, which we don't see here because they left, but these objects, which are there, we did capture, were reflecting sunlight. And that's why they appeared up bright, is that they were in a position to reflect sunlight. And this indicates perhaps some sort of coordinated network that was monitoring the Earth in the 1950s when we had multiple significant UFO flaps. 1952, 1954. UFOs over the White House. That's what some people observed. And we have all sky survey data to suggest that perhaps we had some things in our solar system that we were completely unaware of at the time, and that potential exists. As it relates to 3i Atlas here, We really simply have no clue what the heck this thing is, but I will say I think it's bringing in a lot of interstellar energy. We don't know if it's made of matter or antimatter. We don't know if it is an alien craft or not. We don't know if it's going to cause increased solar activity or not. Will it impact Mars or not? It doesn't look like it, but again, no one knows. So this is a very, very bizarre thing. I would highly recommend you do your own research into this. Take everything with a grain of salt, especially this video, because we are just exploring all these interesting ideas that exist. There is no set understanding of our cosmology. Everything is being rewritten right now, especially with the launch of James Webb, and it's pushing back all these boundaries and expanding our view of the cosmos, and more people are coming out publicly and saying Big Bang is dead, and that was the bedrock of our cosmology for decades now. So we are really back to a similar situation where people believe that the Earth was the center of the solar system, everything orbited around the Earth, versus the heliocentric revolution. That is where we are right now. 3i Atlas, that is my video for you on it. I'll be making more videos on this, but I just felt I had to get this information out there in the best way possible. It's a lot to kind of hold on to, a lot of information. So I'll be making more videos on this. If you'd like to see that, then please subscribe to the channel, smash that like button, help the channel grow. Again, I've been your host, Stefan Burns. What we track on this channel is what's happening with the Earth energetically. So that's like, for example, these volcanic eruptions in Russia, the megaquake that occurred, all the geophysical energetic changes that are unfolding, solar activity, space weather, planetary resonances, and these sort of cosmic forces. What is the cosmos itself? Is it different than what we've been brought up to believe? These are the questions that I'm exploring. I hope you find that interesting. I do not claim to know everything or be God or be the sole proprietor of the truth, but I'm doing my best to exhume the truth out of the mana that surrounds us, and that is my journey. So if you'd like to stick around for that, then happy to see you here. Wishing all of you well. Please take care of yourselves, and I'll see you all in the next video.